Hello everybody, I hope you are doing well, and I also hope that you remember that on Friday we didn't have time to finish our second example. In this video, I will just provide the remaining part of the solution to example number 2 from Friday. Without further ado, let's dive straight into it. I believe that we left our problem here, yes, with these two equations and two unknowns. Our unknowns are f, t, and ay. So we just, in order to solve this system of equations is not solvable, right? And we must find third equation so that our problem, our example will be solved. In order to do so, we should look at the relative motion. So I hope that you recall this expression from Tuesday's lecture. And we already found these two parameters, AB and AA. Now our goal is to gather some information about ABA. Okay, this is our goal in this video. So I would like to, in order to gather the information about ABA, I would like to start with finding the relative trajectory between points A and B. In other words, if you imagine that you sit on the trolley or you travel with the trolley and you have a look at the crate. So imagine that you are here and you travel with the trolley and you look at the crate. What relative trajectory you will see there? And I believe that you guys told me on Friday that the relative trajectory will be circle. It will be circle. So let's draw that circle in our picture. So this is our relative trajectory. I will just underline the word relative trajectory. It's a circle. All right, so since we know our trajectory, let's try to express that relative motion in one of the curvilinear coordinate systems we learned recently. I would like to propose that we express that motion in normal tangential coordinate system. Normal tangential chords. All right, so I will just put in here UN. I will put in here UT. All right, and our accelerations will look like that. They will have these two components, AN relative and AT relative. And these two vectors are also expressing relative motion. So I'm going to put superscript rel in here. All right, so let's write down this in a mathematical form. So our ABA is equal to AT relative UT plus AN relative UN. And I bet you guys remember that expressions for our AT and AN are following: dV relative dt UT relative plus V relative square divided by rho UN relative. I I also believe that you remember that our system starts from rest. So this value will be 0. System starts from rest. Yeah. Not only this value, if system starts from rest, you can basically set up every single velocity or angular velocity to 0 because system is at rest. And this simplifies our problem tremendously, right? Because now we can see that our ABA has only one component, right? It only has AT rel UT. Okay. In other words, we can erase this vector. Yeah. Our ABA has only this one component. Great. This is actually all of that abstract thinking process is to realize that this component is 0. Yeah. We did all of that. We spent all of that 6 minutes of this video just to realize that one of the components of our ABA is 0. But now we are able to actually find it. So let me write down this equation right now. The equation of relative motion. So AB is equal to AA and so right now we found ABA, right? ABA is equal to AT rel UT. I think that AB we found earlier in the previous video, yeah, earlier in the discussion, and ABA had only this component, AYJ. When it comes to AA, it is given. It is A star P, right? So now let's plug in these 3 vectors in this equation, okay? Let me do it. So we will have in here AYJ equal to A star P plus AT rel UT. Please observe that these 3 vectors are expressed in 3 different coordinate systems. So right now we cannot do anything with this formula, but before doing something with this formula, we must bring all of these 3 vectors, these 3 unit vectors, by the way, to one coordinate system. Let's bring them to I and j. Let's express this vector equation in ij coordinate system. Okay, so I think that vector p will have such components: cosine 25 degrees I plus sine 25 degrees j. How do I know that? I know it based on this picture. Just please recall that this angle was 25 degrees. Okay, and our vector p is aligned with A star. So its projections will have exactly cosine theta and also sine theta. All right, that's why I know how to express p in ij coordinate system. Okay, when it comes to ut, I bet that ut is expressing qt is much simpler because it will be only minus I. Yeah, let me scroll up the board one more time, and you can clearly see that utrel points out in the opposite direction than I. All right. So now let's do it. Let's do that. Ayj is equal to a star cosine theta I plus a star sine theta j minus atrel I. Okay, let's group our components. So we will end up with a star cosine theta minus atrel I plus a star sine theta minus ay times j. So we can see that we have a vector equation. Actually, so we have one vector equation. That means that we have two scalar equations, and we have 0, 0 on this side. This is actually a zero vector. This should be a zero vector. So that means that this has to be equal to 0, and this has to be equal to 0. These two components have to be equal to 0. Okay, so we can clearly see that atrel is equal to a star cosine theta, and ay is equal to a star sine theta. Let's plug in values. I think that a star was equal to 1.2 times cosine 25 degrees. And in here we will have exactly the same, but with sine. Please grab your calculators and find that this value is approximately 0.507 feet per second square, and this value is approximately 1.08757 feet per second square. Great. We found our every single acceleration in our system, right? Because right now we can write that AB is equal to AYJ, right? So this is equal to 0.507 J feet per second square, and ABA, so our relative acceleration, is equal to AT relative minus I, right? So that would be equal to minus 1.08757 I feet per second square. And this is answer to part A. Yep, they ask us to find ABA. Just please look at the problem statement. Yep, and we found it. We found it, so I can put this green mark in here. But now let's look at those two equations we started with this short video. Yep. Two equations. I'm gonna copy them. All right, so earlier we had three unknowns, right? However, please look here. And one of these unknowns was AY, but we just found AY here. AY is equal to 1.08757. That's why this is no longer unknown. And we ended up with two equations and two unknowns. Yeah, because unknowns are right now f and t. And this is solvable. Okay, I believe that they ask us to find t. So let's do it quickly. I know that you know how to do it. Just let me spend like 60 seconds on that. So from first equation, f is equal to mg plus may. Let's plug in values. So f is equal to 500 plus 500 divided by 32.2 times the value we just found. Oh, I made a little mistake, yes, here. Ay is not this value, Ay is this value. Sorry. So let's plug this value here. Grab your calculators and obtain that our F, so force in the cable, is approximately 507.875 pounds. Okay, and now we are ready to find our T, because from second equation, T is equal to MA star plus mg sine theta plus f sine theta. Please plug in values. So our t will be equal to 40 divided by 32.2 times 1.2 plus 40 sine of 25 degrees plus this value we just found, 507.875 times sine 25 degrees. Please grab your calculators and obtain that t is approximately 233.0327 pounds. And this is answer to part B. Great. This is the end of the problem. This is the end of the example. I hope I shed some light on the dynamics behind this problem. I hope the solution steps are clear for you. Please, one more time, please at home, just chew on it, okay? Please digest what happened in our discussion, yeah, because the first part we covered in the discussion. And please also chew on this relative motion part, okay? And the entire solution. I think of having like a Q&A about this problem at the beginning of our next discussion, okay? So you will all of you will have chance to ask questions in case something I said in those videos was unclear. Okay, I think that I have nothing else to say. I hope you enjoyed these videos. I hope that you enjoy our YouTube channel. Yeah, thank you for listening and have a nice day. Bye.